I want to walk you through chain rule. Okay, and I want to welcome you to chain rule. If you want to understand chain rule, don't forget to understand the fundamentals, the differentials. Okay, so sign U, when differentiating sign U is going to be cos U. Differentiating cos U is going to be negative sign U. Differentiating tan U is going to be sec square U. Differentiating cot U is going to be negative cosec square U. Differentiating sec U is going to be sec U tan U. And differentiating cosec U is going to be negative cosec U cot U. So just wanted to take note of that. Now, when do we apply chain rule? Okay, I'm actually going to walk you through that now. So let's go to question number 43. Okay, I'm going to walk that from the first principle. Okay, we take a look at this guy right now. If y equal to cos x, cos 4x, you know, before we normally have cos x, but right now we have a cos 4x. So which means in general form, you may have y equal cos, okay, cos ax, where a is a constant and s is the variable. So what we're going to do, using the chain rule, okay, we're going to let something to be equal to the whole of this using the chain rule. So I can say let, okay, or maybe P, okay, equal AS, okay, let P equal to AS. And if P equal to AS, you know, like I said, the A here can be 4, can be 5, can be negative 3, but here now is 4. Okay, so using the chain rule is just, I'm actually going to break it down. I'm going to break it down into 2, and that's what I'm doing right now, breaking it down. Y equal to that, so, you know, it means I'm actually going to have y equal cos P, yp equal as. If I want to find the y ds, okay, if I want to find, okay, ddsy, the ddsy is actually going to be differentiating this, is going to be the y dp, okay, I'm actually going to have the y dp, okay, multiply by the pds, multiply by the pds. Of course, you know, the p cancel the p, it means I have the y ds. So what is the y dp? So the y dp here now is different, you know, differentiating this guy, the y dp, okay? So the y dp right now differentiating this guy is going to be negative sine p, okay, negative sine p, then multiply by what is the pds? The pds, don't forget, is a constant, right? The pds is actually going to be a, okay? Now, what am I going to have? Don't forget, it's a constant. I'm actually going to have minus a sine, okay? So what is p? So p, in this case, is actually as. You see what I have for general one? Now, if a equal to 4, okay, it means for this one, okay, the y ds is going to be negative 4, okay, negative 4 sine, negative 4 sine 4x, okay, negative 4 sine 4x. So if you go to number 43, okay, you're actually in the composite, you can see that was why they got negative 4 sine 4x, okay? And that is actually going to be super cool. Now, if I want to solve question 53, okay, if I want to solve question 53, I'm going to go back to 53 now. Okay, now I think I've used a chain rule right now. Okay, I want to solve for question 53. I can solve question 53 in 2 ways. I'm going to use the chain rule. I'm also going to use a conventional way. But let me first, if I have, if you take a look at the 53 here, let me show you. In the 53, in the share rule side, give me 1 second. In the 53, in the share rule side, okay, we actually, you can see what we have, okay, here. So the final answer they got was 8 x squared times x. So let's see. They got 8 x squared times x. Okay, so let's see how we're going to figure it out. Okay, I can write the answer down. 8 x squared. Okay, h x squared. Okay, x squared times x is going to be the final answer. And I'm going to show you how differentiating that. We'll give you 8 x squared times x. If you come here now, okay, I can rewrite this guy as 4. Okay, x squared u, we actually mean, I got sec or squared. Okay, x squared is or squared. Okay, x squared x or squared. Take a look at that. If I want to use a share rule right now, I can let, y, okay, so if I let maybe p equal sec s, okay, if I let p to be sec s, I'm actually gonna, my y now is gonna be 4p squared, right? 4p squared, right? Okay, so if I have this guy now, I'm actually, I actually want the y ds, right? Okay, which is DDSY. If I want to find the DSY, I need the PDS. Okay, I'm actually applying share rule. The PDS, right? Okay, multiply by the YDP, right? Multiply by the YDP, right? So, what is the PDS? Okay, I want to differentiate sec s. Okay, I told you the other time, differentiating sec s is sec s times u. Okay, so I'm actually gonna let me borrow the space from here. I'm gonna cancel that. So the YDS right now. Okay, so the YDS is gonna be equal. So what is the PDS? The PDS, like I said, differentiating sec s is from the standard rule. Sec s times u. Okay, sec s. Okay, sec s. Okay, tan x. Okay. Okay, which is what I have differentiated the PDS. So right here now, differentiating, having the YDP now is going to be 8p. Okay, so multiply by 8p. Okay, so if I want to write my final answer, now I'm going to write 8. So what is my P? Okay, P is sec x, right? So it means I'm actually going to have sec x. Okay, and here, sec s times x. Okay, sec s. Okay, tan s. Okay, now multiplying all of that. Okay, you're multiplying this by this guy. I'm actually gonna have 8. Okay, sec squared x. Okay, tan x. Okay, tan x. Okay, so which is the answer that we got? Which is the same thing as what we got. Super easy, right? That's actually how to, that's how to do that. Okay, that's super cool. Okay, now you can actually try other, you can try other questions. It's gonna be super easy. If I take you to the other one, I can quickly explain how they got the other one to you, but that's kind of easy. Take a look at this. So I have h of t equal cos square, all of this. So what I'm going to do, I can make this guy here. Okay. If I want to write that, everything here is going to be, cos, cos of this, everything squared. So we can write as 2 something squared, then I'm going to let you to be cos pi t plus 2. So which is going to be, that's why I say cot u. Okay. The moment you have cot u, and don't forget, if I let u to be equal to, cot, into pi t plus 2. Okay. When I do the same, what I did here, I differentiate, you know, u with respect to t, and I differentiate h with respect to u. I'm actually going to have that, to multiplying that, and that's going to give me this. Okay. The same way I'm actually going to do here. So you can go through that. Okay. They're all going to be super easy. Okay. Now, the last thing I'm going to do, of course, I walk into explicit differentiation the other time. Okay, so what I'm going to do, let me see. I'm going to attempt this one. Okay, and maybe I also attempt maybe one of these. Okay, this I've signed a course. Okay, I can attempt this and this for you to be able to see. I want to welcome you to implicit differentiation that involve trigonometric function. Of course, the other time I walk you through implicit differentiation. Now, we take a look at this. I want to differentiate this guy because the question says differentiate everything, right? So differentiating this guy now, don't forget it's going to be cos x. Okay. Now, plus. Okay, I want to differentiate this guy now. Okay, like I said, if you force differentiate this guy, if you make this to be u, okay, don't forget, if you make that to be u, you're actually going to have cos, okay, u, right? Or maybe we said we let h to be equal to cos u, and don't forget, u is going to be equal to 2y, right? Now I'm going to do the h, the u. The h, the u is going to be, don't forget there's a 2 here. So I'm going to write the 2. So the h, the u is going to be negative sine u. Okay, negative sine u. Okay, then multiply by, I'm going to do the u, the y. The u, the y is going to be 2 the y dx. When I differentiate this one, it's going to be 2 the y dx. So I'm going to clean that one. I'm going to write 2 the y dx. So 2 the y dx. Okay, 2 the y dx. Okay, equal. I'm going to differentiate 1. That's going to be 0, right? Okay, in implicit differentiation, we want to make the y dx to be the subject of the formula. So what I'm going to do right now, so it's going to be cos x. Okay, I'm actually going to have cos x. Okay, plus minus, they're going to be negative 2. Okay, in fact, I can do 2 times 2 here, so I can get 4. Okay, so I'm actually going to have 4. Okay, now sine. Now instead of u, our u is 2y, right? I'm going to have 2y. Then the y, okay, ds. Okay, the y ds equal to 0, right? Okay, now looking at to the other side, you're actually going to have sine, okay, 2y, okay, the y ds, okay, the y ds, okay, equal cos s, right? So you want to make ddxy, you want to make this guy the subject of the formula. Okay, so if you want to make that, I want to borrow a rule from here. So I'm going to have ddx equal cos x, okay, cos s, okay, or divided by 4 sine 2y, 4 sine 2y, okay? Now, this guy here is actually the final answer. So if I want to look at question 11, okay, so what it got for question 11, you can see right here, cos s over 4 2y. Okay, that's all we got. Okay, now I'll quickly explain the other one, okay, which is this. Okay, now it's gonna be the last one I'm actually gonna do before I go. Okay, I'm gonna be the last one I'm gonna do before I go. So I'm gonna clean up right now. Okay, so when I'm doing my cleanup, what I'm actually gonna do, because I need a space. Okay, give me 1 second. I think I'm gonna write it. Oh, give me 1 second. Okay, so because I need a space right now, because I need a space right now, um, I'm actually gonna clean this one. Right? Okay, I'm gonna clean this one out. So, and this is for this. I want to do sine s equal to x into 1 plus tan y. So, what I can do first, okay, I can for simplify sine x, okay, equal, okay, x times 1 is x plus x times y. Okay, now it's going to be easy now. We want to differentiate that, right? So I'm actually going to come here differentiating sine s. That's going to be cos s, right? That's going to be cos x equal differentiating x. That's going to be 1, right? Now differentiating this, don't forget you're going to use a product rule because we got a combination of x and, 2 different functions. So what I'm going to do, okay, you remember the other time I was talking about f and g, differentiating x, that's going to be 1. Okay, then write tan y, okay, after that, plus, okay, we differentiated it, we write it, so we're going to write x right now, and we're going to differentiate tan y. And don't forget, tan y is going to be sec square y, it's going to be sec squared y, the y ds, okay, it's going to be sec square y, the y ds, don't forget. We need to make the y the subject of the formula, right? So that's going to be cos x, okay, equal 1 plus tan y, okay, 1 plus tan y, okay, then plus x sec square y, okay, sec square y, okay, the y ds, okay. So all what we need to do, we actually want to make the y the subject of the formula. So if I'm going to make the y ds, the subject of the formula. Okay, I'm actually gonna have cos x. Okay, I'm gonna have cos x. Okay, so when I have cos s, I'm actually gonna have minus one minus tan y. Okay, minus tan y. Okay, minus one. Okay, and everything divided by x. Okay, x squared y. I want to believe that's going to be the final answer. So what I'm trying to tell the world, like the y dx equals cos x minus tan y minus 1 divided by x squared y. I'm actually going to check in the answer key on number 13 right now. Okay, so you can see what we have is the same result. Okay, you can go to others. You can also go to some other question. I think I uploaded a lot of materials, okay, for you to, you can practice, take a look at all of that, okay, and the answer keys are there, okay. Make sure you all stay safe and have a lovely day. Bye for now, everyone.